Students, Mr. Wertz coming to you with another Algebra 2 video. In this one, we're tackling the compositions of functions. So in this video, guys, we're going to learn how to compose two functions together. We're doing this because when you solve systems, you need to be able to run an input through multiple functions. And you'll know you're successful when you could take a function, composition of functions like f of g of 3, and run it through two functions that are specified f and g. So let's get started. So in this, the first thing that we need to know is that a composition of functions is an algebraic concept, and it is such that when you take an operation, it takes two functions like f and g, and then it produces a function h such that h of x is equal to g of f of x. So I know that's a lot to say, but it's g of f of x. That means, that is that the function g is applied to the output of applying the function f to some input x. So it's visualized here by this image. Let's pretend that we have a bunch of inputs a over here, and we apply some function to them, and we get some outputs here. Then when we apply another output, or another input rule, and then put that into function g, we get a second input, or second output. So essentially, we can say here that 1 will create 2 in the very, very end. So that would be g of f of, and then 2 creates 1, 3 creates 2, and 4 creates 3 in the very, very end. So essentially, we are taking the input of one function, running it through, getting an output, and then using it as the input of the other function. So in practice, though, it's important with the composition of functions and functions in general that we work from the inside out. Remember, because of the order of operations, when you have two sets of parentheses, okay? So I'm saying when you have a set of parentheses, and then within the parentheses you have a second set of parentheses, you would start in here first, okay? So using the proper notation, f of g of x, you're taking this input and you've got to go into g first, and then you have to go into f, because it's specific with PEMDAS that you need to work from the inside out when we have multiple parentheses. So watch out, because f of g of x is telling you to evaluate x and g first and then use the result in f. But if you write it the other way and say g of f of x, it tells you to put x or whatever the value is into f first and then evaluate that in g. So let's see how this kind of works out in a more visual way. I'll get to some examples, but I do need you to know that compositions of functions are two-step evaluations. So you need to remember your evaluations rules. Remember that the evaluations were section 1.2 was when we were evaluating, actually it was section 1.3, excuse me, when we were evaluating equations, expressions. You need to pay attention to the extra attention to the order of the composition. It's really important that you make sure you have g of x or f of x in the correct order. And then you also need to know that we can compose two functions together. More on that later. Right now I want to show you some examples of composing two evaluations together. So, for example, if I have f of x is equal to 2 times x plus 3 squared, and I have g of x is equal to x squared minus 1 divided by x plus 1, then f of g of 3 equals what? So they're asking me in this problem, I've been asked, mathematically instructed to take the 3, and I have been instructed to insert the 3 into, and I'm going to use my highlighter to show you. They're saying g of 3. So I have been instructed to use this function, function g, and substitute 3 in for all the x's. So I'm going to do that. And remember, when we substitute, okay, don't be lazy. Use parentheses to show that you have substituted something in place of the variable. So you should be using, parentheses 3 squared, okay? Don't be lazy, use it. It makes a big difference. Minus 1 divided by, the bottom would be 3 plus 1. Okay, so I complete my evaluation by simplifying. On the top of the function, I'm going to get 3 squared is 9 minus 1. On the bottom, I still have 3 plus 1, so I did the exponents here. So g of 3 simplifies as 8, and 3 plus 1 is 4. So then I finally do the division of the fraction. So g's value of 3 is an output of 2. So I essentially have just created a coordinate 3, 2. Now I am going to take, let me get my highlighter here. I'm going to take 2 because it's what g of 3 is equal to. And I'm going to substitute it in f in place of the x. So I'm going to now use f of x over here. So f of, instead of x, I'm going to write 2 now, because 2 is what g of 3 was equal to. So we take that and we put it into the other function, 2 times, and then I'm using parentheses, 2 plus 3 squared. All right, so I'm going to go ahead, take my highlighter, and just confirm, the 2 that was in here comes from the g of 3. So now what I'm going to do is evaluate this function. I'm starting with the inside, the parentheses here. 2 plus 3 on the inside is 5. So f of 2 equals 2 times 5 squared. Okay, so I evaluated my parentheses. Now I'm going to evaluate my exponents. So I need to do 5 to the second power. So I get f of 2 equals 2 times 25. So then f of 2 is going to be equal to 50. So then it can be said that f of g of 3, I'm actually going to highlight this, f of 2. And the reason that I highlighted it f of g of 3 is because, or in yellow is the same color as that, is because this value, 50, is now the equivalent statement of f of g of 3. It is what happens when you send 3 through g, take that result and send it through f. So I can now say, to complete my statement, f of g of 3 equals 50. And that's the first example of numeric evaluation, a numeric composition of functions. Let me continue. I have another example where f of x equals the square root of x plus 5, and g of x is equal to x squared plus 2x minus 5. What is g of f of 4? Okay, so in this one, they're actually giving, they put g on the outside. So if I'm approaching this problem, I see that f of 4 is what I am going to need to approach first, because it is inside. So insides go first. So I get f of 4 is going to be equal to the square root of 4 plus 5. And 4 is what took the place of the x. And I actually broke my own rule and forgot parentheses. So I'm going to go back and fix that. No breaking rules. Math is made of rules. So f of 4 equals. So now I get the square root of, and I simplify 4 plus 5 is 9. So then I'm going to go ahead and say, I can actually evaluate that, and I can say that f of 4 is equal to the square root of 9 is 3. So this 3 becomes the input for my other function, g. And so g is going to get 3 put in for all of those x's. So I'm actually going to evaluate it as g of 3 equals parentheses 3 squared plus 2 parentheses 3 minus 5. So g of 3 is equal to, so 3 squared is 9, plus 2 times 3 is 6, minus 5. So g of 3 is equal to 9 plus 6 is 15, minus 5 is 10. So I can say now that g of f of 4 is 10. And if you think about it, all right, f of 4 is 3, so then g of 3, I basically made a substitution just in that in order to find my final answer. So just another example. If f of x is 4x and g of x is equal to x to the second power plus 1, then f of g of 5 equals what? Okay, so again, they're telling me, all right, they're saying, hey, you need to take g, you need to take 5, and you need to put it into g. So g is going to get 5 here, here. So I get g of 5 is equal to 5 squared plus 1. So if I quick simplify that, I know that 5 squared is 25. So I get 25 plus 1, or 26. So skipping over, I'm going to substitute this value, okay, into the other equation. 26 is going here, and I'm actually going to show you what it looks like when I substitute an entire value in here. So I'm going to say f of g of 5 is equal to, and then f has a 4, and x should now be 26. Because g of 5 is 26, okay? So we pulled this information directly from that last statement. G of 5 equals 26. Well, g of 5 is here, and 26 is here. And I was told to find f of g of 5. Well, that is exactly what I am finding on the left side of the equation. The only thing that remains for me to do is to actually simplify the right side of the equation. So f of g of 5 is equal to 4 times 26, which is 104. So f of g of 5 equals 104. Okay, so composing variable functions. Sometimes, okay, we have to compose two functions together, but we're not given a numeric input for it. When this happens, we're not evaluating anymore so much as we are substituting and simplifying an expression. So you're going to take the inner function, and you're going to substitute that inner function's, what it's equal to, its contents. You're going to substitute that into the other function in place of the variable, and simplify if it's reasonable. So here's what that looks like. All right, f of x equals 2x plus 2, and g of x equals 4x minus 3. Then f of g of x equals what? Okay, so they are saying for us to consider that g of x is equal to 4x minus 3. Okay, so I'm going to take this yellowed expression here, and I'm going to substitute it in here, and I'm going to substitute it in here. I mean, I'm technically going to do, if I'm getting really technical here, and I should, this is going in here. And then the expression 4x minus 3 is getting placed into the function f. That's what it means to evaluate a composition of functions when you have nothing but variables. So I'm going to get f of g of x equals. And so in place of x, I'm going to write this yellow 4x minus 3. So it's going to be 2 and then parentheses. This is why you need to use parentheses, okay? Because now we are going to have to multiply this expression 4x minus 3 times 2. As part of our simplification, and then it's plus 2 on the end. So notice that in the expression here, where there was an x, there is now 4x minus 3, or there's g of x, which is exactly what we want. We want f of g of x. Okay, this is my goal on the left side. Now all I have to do on the right side is to actually simplify it. So to do so, to simplify it, I know that I must distribute first. So I get f of g of x as it stands on the left side of the equation, and I should, equals 2 times 4x is 8x, 2 times negative 3 is negative 6, and I have a plus 2 on the outside. So the last thing that I have to do is combine my like terms. So f of g of x equals 8x, and then negative 6 plus 2 is negative 4. So f of g of x in this situation equals 8x minus 4. So if f of x, here's another one, and it involves exponents, and it's really good to get a handle on these exponents now because we are going to be seeing them. If f of x equals 2x minus 1 and g of x equals x squared minus 3, then g of f of x is equal to what? Okay, so what I am going to do is understand that I'm going to be taking this expression and substituting it here. And f of x, the whole thing is going to go in here. So on the left side of the equation, I'm going to get g of f of x, okay? And that was fully intended. That is exactly what I wanted. G of f of x, I wanted it in here, equals. So now I'm going to start by writing parentheses, and I'm going to place this 2x minus 1 in there. So 2x minus 1 to the second power, take away 3. So if I take my highlighter, it is in here, where it should be. So now what I am going to do is simplify. And I am going to simplify by squaring 2x minus 1. So if you don't remember, 2x minus 1 squared actually means this. It is 2x minus 1 times 2x minus 1. So I'm going to quick multiply everything out here. 2x times 2x is 4x squared. 2x take away 1, or 2x times negative 1 is negative 2x. Negative 1 times 2x is negative 2x again. And negative 1 times negative 1 is positive 1. So I get 4x squared minus 4x plus 1 when I square that out. So what I am going to do now is, and I messed up my 4 here, I am going to take the amount 4x squared, and I am going to substitute it. I'm going to highlight it here to show, and I'm going to highlight it in blue. This is going to take the place of this, because that is exactly what we were attempting to do, was simplify. So on the left side of the equation here, I'd just like to duplicate this to make my thing go a little faster, equals 4x squared minus 4x plus 1, and then I have the takeaway 3 on the outside. So again, that comes from the blue solved equation, or excuse me, the blue multiplied out expression over here. So my final answer is going to be that g of f of x is equal to, what the heck, is equal to 4x to the second power minus 4x, and then 1 plus 1, take away 3 is negative 2. So that is my fully simplified expression. And finally, the last one, the last example that I have here is if f of x is equal to x squared plus 2 and g of x is equal to the square root of x minus 1, then f of g of x equals what? So again, they are telling me that I need to take g of x. So I'm going to take this whole expression and I am going to substitute it here. And I am going to highlight in green, again, that g of x is going to be taking the place of this x over here, so I complete the expression. So I get f of g of x equals, and the f of g of x here is in green, the g of x, that's where it came from. So it equals the square root of x minus 1 squared, because we are replacing this x with this whole expression, plus 2. So I just need to get my yellow highlighter in order to demonstrate that. So this whole expression took the place of x here. So on the left-hand side of the equation, or the left-hand side here, nothing happens, and nothing should. You should not be attempting to simplify this whatsoever, okay? We're not attempting to simplify that at all. But on this side, when you take the square root of something and then raise it to the second power, you square it, they undo each other. So if I take my, I'm going to get a creative pen here for you guys. Happy face. This cancels with the 2 up here. All right? So, whoop, they're gone. They're happy and they've run off together. So all that I'm left with is what's left, what was underneath. So I get x minus, and I put my minus in a bad spot, x minus 1 plus 2. So when it all comes down to it, I can then say that the f of g of x is equal to x, and then negative 1 plus 2 is positive 1. So that's it, guys. We can compose 2 functions together by evaluating them in sequential order for some given numerical input, but you have to pay extra attention to the order of composition, or you'll do the composition in the wrong order. The 2 functions can be composed even if you're not given a numerical input to evaluate. That was what I did with the variables, and the visualization of this entire process is summed up with the picture below. So that's it for the video, guys. Thanks for watching, and I will see you in the next one.